Hello, good afternoon, my dear students. How are you all? Welcome to one more awesome session from Infinity Learn, India's biggest exam preparation platform, Infinity Learn by Sri Chaitanya. मैं हूँ सुरेश faculty of chemistry. Welcome to the session. Hi, my dear students. How are you? Yes. Good afternoon. Fine. So, have you seen NEET result in yesterday's? Yes, 720 is the highest score we got. I think 3 students from Infinity Learn we got that great score, expecting so many more and many more. Hi all, how are you? Right? Okay. So, welcome to the session. These sessions are intended for NEET 2025 step-up program. Ishita, hi, good afternoon. Right. So, in this NEET 2025 step-up program, we are conducting physics, chemistry and biology, right, from 12 o'clock every day afternoon till evening 6 o'clock, and we will be conducting physics, chemistry, biology sessions on a regular basis, and you will be completing all total syllabus at the NEET level. And in this YouTube channel, you please, hi Sangampal, hi, good afternoon, good afternoon. So, all the sessions will be given with all topics. So, we request you guys, you please like these sessions and share with your friends, okay, and subscribe to the given channels in the chat box and description box, okay. So, these sessions are especially planned and designed by eminent faculties, and these sessions are useful for those students who are in the grade 12 and dropped grade 12 and preparing for the next NEET 2025. Also those who are in grade 12 passed from 11th, and they will also write a NEET 2025 program, right? Hi, shall we start? Hi. Okay. So, yesterday we could not conduct the class because the session did not go live because of the NEET 2024 results. So many fabulous celebrations around Infinity Learn over here, so that yesterday's topic it could not be. In this NEET program, I am Suresh Avari, chemistry faculty, and we designed the program in such a way that 6 days a week. First 3 days we are talking about 11th standard, and the next 3 days we are talking about a 12th standard. So, today is Thursday, we are in solutions and colligative properties lesson number 2. So, we discussed solution colligative properties previously about types of solutions and concentration terms. Your Saranya, hi Saranya, you all attended. Have you seen the recording of Saranya? Recording of this session, Saranya, right. So, you all can do this, just a minute. Yes, no problem. So, going back to what are the topics we covered? Saranya, please watch the recordings if you are not available in the live session. So, I prefer you guys to attend live sessions. If live sessions you are failed to attend due to any other reasons, you just watch the recording of these sessions. It helps you a lot. Okay, talking about solutions, what we learned so far? We learned solutions, types of solutions we learned, methods of expression, concentrations we learned, and we will start vapor pressure and solubility also in today's class, and Raoult's law, that is the course, colligative properties, abnormal molecular mass, अगले class का आना है. So, these are the things we did in the session 1, right? These are the things we already completed in session 1, and today's plan is going to be vapor pressure and Raoult's law. So, in NEET examination, you will be having one question from this particular solutions topic. So without a question from this particular topic, you don't have NEET paper. So that importance of the solutions topic, you all just carry a notebook and a pen and attend the class as it goes as a flow, right? So we'll start. So 1.5 factor abnormal molecular mass में आएगा. So we will be discussing these two in tomorrow's class, and we consolidate all the things and the question discussion in this. Okay, we are all expecting Ishita, we are all expecting some more students to join. So meanwhile we'll just go with the revision. That's what happened here. So types of solutions is a homogeneous mixture, right? So it's a binary solution. A binary solution means it has two components, one solute and one solvent, right? So solvent determine the physical state. If it is a water is a solvent, that is called aqueous solution. If alcohol is the solvent, you can say it's alcoholic solutions. So types of solutions, we have solid solutions, liquid solutions, gaseous solution. It is just recapture, my dear students. You just all follow this. Okay, so you have a table based on the types of solutions. It is a solute classification, solvent, and if these two are mixed, these are the common examples. Okay, so what do you say if air is a mixture of nitrogen and oxygen? So it is a gaseous solution, right? Okay, now so aqueous, non-aqueous we discussed, right? So methods of expression concentration terms, you have weight, percentage, we discussed all these things. So मैं कह रहा है कि ये जो फॉर्मूला है चीट शीट बनाना के बोला मैं, कितने जन चीट शीट बना दिया अभी तक? चलो कमान, कितना बना? चीट शीट अभी भी बना सकते हैं ना, राइट? Talking about weight volume percentage, so go back to the weight percentage, weight of solute upon weight of solution, right? अभी तो weight volume percentage, weight of solute upon volume of solution, right? So volume भी होता है. So volume, the term itself indicates a कौन सा करना है, volume of the solute upon volume of the solution. समझ में रह गया, right? Just recapture. Talking about molarity, it is the number of moles of solute present in a liter of solution. So इसका फॉर्मूला है, ये काफ़ी ज़्यादा इस्तेमाल करते हैं. Weight molarity is equal to weight of the solute upon gram molecular weight into 1000 by V volume of the solution expressed in milliliter. Confusion छोड़ दो. Understand? You all got it? Ha. Right. Now we'll talk about if different terms are there in the NEET examination. In the NEET examination, you will be giving a molar solution. A molar solution का मतलब उस solution का molarity 1 होगा. Okay, A semi molar solution, a molarity m/2 or molarity is 0.5 molar. A decimolar solution, deci means m/10, centimolar solution m/100. Like that, these terminologies are important to understand the questions in the NEET examination. So you won't be given any kind of digits. Rather, they use a decimolar, a semimolar kind of terminologies. Everybody kindly note it. It is very important. Okay. So let's go. They are in the common use. And if molarity, so if the molecular mass is given, okay, the mass of solute, okay, in grams present in V liters of solution can be calculated from the molarity of the solution, that we know that. Okay, weight of the solution, simply you see molarity is equal to number of moles by volume, right? So number of moles is equal to molarity into volume, right? So number of moles can also be written as weight into gram molecular weight. So from this you can mathematically calculate the other parameters. If it is millimoles, you can simply write so 1000 1 mole is equal 1000 millimole. ये कन्वर्शन काफ़ी इम्पॉर्टेंट है. जब स्टोइकियोमेट्री के इस्तेमाल करने हैं ना, ये आपको काम आ जाएगा. एक मोल इज इक्वल 1000 मिलीमोल्स. समझ में आ रहे क्या? इशिता, हाय, right? You are all able to hear me and you cannot see me, right? Right. Okay. Okay. Right. Let us go ahead. Some useful relations. Number of millimoles is equal to molarity into volume if the volume is expressed in milliliter. ख्याल में रखो. Right? And number of moles, so that is mv by 1000. Number of moles of solute, that is mv, we already discussed. And when a solution is diluted, its molarity decreases, right? So when the solution is decreased, when this solution is diluted, you have to use this, that is what you call it as dilution law. Dilution law. M1 is molarity before dilution, V1 is volume before dilution, and M2 is molarity after dilution, V2 is volume after dilution. Children, hope you are all understand. This is very important. काफ़ी important formula है. सब लोग cheat sheet बनाना बोल रहे हैं. So how many of you made cheat sheet so far? I am asking, give in the chat box. Come on. Right. Yes. Yes, how many of you made cheat sheet so far? Want to know कितना जन है, कितना बच्चा है? और चैट बॉक्स में कुछ संगम, शरण्या, you want to make a cheat sheet? So all the formulas I am making in the box, write in a format in a single sheet and keep in your database so that you prepare before you go into the examination. So when you are just about to start the exam, एक बार आप फार्मूला शीट में देखना, अच्छा होगा, रिकॉर्ड होगा. फोटोग्राफिक मेमोरी भी होता है ना बेटा? अरे कुछ बोलने यार चैट बॉक्स में, कुछ बोलने यार. राइट. Okay, moving ahead, this is about dilution law. You all able to hear me? Just give a confirmation. You all able to hear me? No response. So I think you are clear, right? Yes. Yes. Okay. Now let's talk about volume of the water added to get the solution of known molarity. So for that you can use V2 minus V1, that is equal to M1 V1 upon M2 minus V1, or V2 minus V1 you can say M1 minus M2. इसमें ये कॉमन निकाल के upon of V1 of M1 you can write it. Otherwise you can say volume of water simply measure like V2 minus V1. That's it. Okay. So next, mixture molarity. This is a simple formula. Generously we use for any kind of calculations. So mostly we use molarity and normality in chemical calculations, my dear students. So if the solutions are mixed, you can go with so when the weight by volume percentage is given, weight by volume काफ़ी important है. W by V दिया गया, अगर W by W देने तो अगले एक आ जाएगा ना. Okay, but here it is W by V. When W by V percentage is given, molarity is nothing but 10 into W by V percentage upon gram molecular weight. समझे? Now coming to, if W by W is given or density is given, molarity is equal to 10 into specific gravity into W by W upon gram molecular weight, or simply density in chemistry we consider as specific gravity also. So that molarity is equal to 10 into density upon W by W upon gram molecular weight. So these are the formulas. So these are the formulas are very important. We have to just find as a ready-made formula. In NEET examination, answering physical chemistry questions are so easy. You don't have so complicated questions. When you see 2023, 2024 NEET examination, न्यूमेरिकल का बारे में इतना स्ट्रेस नहीं देना है, लेकिन ये स्टेटमेंट 1, स्टेटमेंट 2 क्वेश्चंस का ध्यान देना, ओके, असर्शन रीजनिंग में ध्यान देना, सो एनालिटिक्स में ध्यान देना, क्योंकि कॉन्सेप्ट जो आते हैं ना एनसीईआरटी हर लाइन में, हर पेज में, हर लाइन देख के ये कॉर्नर से क्वेश्चन आने का संभावना ज़्यादा होता है. सो यू रीड द एंटायर एनसीईआरटी टेक्स्ट बुक, every page, every line and every corner, you will be having a concept oriented questions. So if you look into the numerical part of the questions, it is around 10%. okay, ज़्यादा से ज़्यादा 5-6 क्वेश्चंस है. सो बाकी जो 40 क्वेश्चन आप यहाँ याद देना, सो फार्मूला रिलेटेड जहाँ पर न्यूमेरिकल आता है ना, so that numerical directly focused related to the formula. That's why I focus, give the formula emphasis. Okay. Hi Vaji. Hi. Say completely say hi. Okay. Let's talk about for a mixture. ये mixture क्या? Let us take a solution whose molarity is M1, volume is V1, is mixed with another solution whose molarity is M2 and volume is V2. So that you are going to get a mixture. So the molarity of the mixture is equal to M1 V1 plus M2 V2 upon V1 plus V2. Noted this? Hi beta. So Vaji, if a student attend these classes regularly, you people will understand. Okay. You try to attend the classes and try to see the previous recording. आपको समझ में आएगा देवाजी. Meanwhile, you just attend the class and try to make you understand better, right, instead of spamming. And if any genuine doubts are there, please ask us, right. So talking about normality, it is the number of equivalents of a solute present in a liter of solution. That is about normality. So normality molarity का जैसा है, but normality में equivalents इस्तेमाल करना है and molarity में moles इस्तेमाल करना है. So gram equivalent weight and gram moles, okay, so ये दोनों का क्या चीज़ है. So gram equivalent weight है ना, that is gram molecular weight upon n factor. We discussed about n factor in the previous class. Ishita, what is n factor? It is भाजी, अब जो बोलना चाहता हूँ ये एकेडमिक्स के बारे में इसी पॉइंट में मैं डिस्कस करना तैयार हूँ. ठीक है बेटा. हाँ. So that gram equivalent weight is replaced in the molarity formula, you will get a normality, right. So it is given simply like a formulas. So some useful relations for this normality also. Avogadro abhi nahi aayega. Okay Ishita. N factor means valence factor, means number of H plus that is given by an acid, or number of OH given by a base, or change in oxidation state for redox change. Okay, yes. So number of equivalents is written with NV. Okay, so normality is equal to number of gram equivalents by volume in liters. So number of gram equivalents is equal to normality into volume. Similarly, number of milli equivalents is equal to NV if it is expressed in milliliters. So the mass of the solute you can also calculate normality into volume into gram equivalent weight. These are the simple formulas. Okay. So if the solutions are mixed, so that N is equal to N1 V1 plus N2 V2 upon V1 plus V2. Okay. So this is just recapture that what is happened in the previous class. I don't want to give much more about that. This is a Khatarnak point. It is quite useful in case of ionic equilibrium and pH calculation also, if acid and bases are reacting. Okay. So if NaVa is equal to NbVb, okay, so A is acid normality and B is base normality. Okay. So if this is case, acid is equal to base, so they get completely neutralized. When they get completely neutralized, the pH is going to be exactly 7. आपका pH स्केल जानते हैं ना? हाँ, yes. Now, अगर NaVa is greater than NbVb, acid जीत गया, so that solution is acidic. pH is less than 7. Okay. If NbVb is greater than NaVa, base जीत गया. अगर base जीत गया तो का मतलब pH is going to be greater than 7. So these formulas we discussed in the previous. Hi Ravindra Reddy, why you are late? Why you are late? Okay. So how to calculate pH from this? H plus ion concentration is equal to NaVa minus NbVb upon Va plus Vb. ये H plus ion पकड़ के pH is equal to negative logarithm to the base 10 of H plus. You can do it. Now, if base is more, OH minus ion concentration is equal to NbVb minus NaVa upon Va plus Vb. It is completed. Now, so this OH minus you got it, so that POH is equal to negative logarithm to the base 10 of OH minus पकड़ना है. So that POH से pH कैसे कैलकुलेट कर सकते रविंद्र रेड्डी? रविंद्र रेड्डी POH से pH कैसे कैलकुलेट कर सकते? Any student in the class tell me? Ishita? Saranya? Come on. We know that pH plus POH is equal to 14. So that pH is equal to 14 minus pH, POH. Got it? Now, so normality and molarity facts. So these are already discussed in this H3O plus and H plus दोनों same है. Ravinder, yes. So simply we can say normality is equal to molarity into N factor. शायद लगता है दोबारा मैं क्लास ले रहा हूं. These are things completed in the previous case. For exact neutralization, weight of base, okay, NaVA is equal to NbVb. Okay, in case of dilution, N1V1 is equal to N2V2. So those students who are not there in the previous class, you please attend here. So that molality एक अलग चीज है molarity से. Molality you have to use by using small m, right? So it is the number of moles of solute present in a kg of solvent is called molality. So the molality you can generously use to calculate this formula. So units क्या होगा? Mole kg inverse. Mole kg inverse, right? So parts per million. परसेंट का जैसे पर मिलियन पकड़ने तो पर मिलियन का मतलब 10 पावर 6 होगा. GMW is ग्राम मोलिकुलर वेट. रविंदर रेड्डी, राइट बेटा? हाँ हाँ, यस. So that we discussed some useful relations. So molality and solubility का, molality and molarity का, molality and specific gravity का. So these are important tricks that you can directly use. Mole fraction and molality का. So these formulas फटाफट एक बार लिख दो, जल्दी फटाफट लिख दो, एक बार प्रैक्टिस भी हो जाएगा सेशन में. रविंदर, इशिता, कम ऑन, चलो मेक इट फास्ट, कम ऑन, जल्दी लिखना. Yes, we always want to do problems. Today we will be doing problems. No worries, Ravinder. Right? Copied? Yes. Mole fraction. Mole fraction is the fraction of number of moles of a component to the total number of moles. So that is called mole fraction. ठीक है? So let us say a compound, a solution is prepared by a solvent and a solute. So number of moles of A, number of moles of B. So the mole fraction of A, okay, is equal to number of moles of A upon number of moles of A plus B. Okay, so it is a component, it's a ratio. So mole fraction is a ratio, so that it has no units. Got it? Has no unit. Mole fraction is indicated by using kind of Greek X. Similarly, mole fraction of the component B, it is calculated by using number of moles of B upon number of moles of A plus B. You want to take mole fraction of A plus mole fraction of B is equal to number of moles of A plus number of moles of A plus number of moles of B plus number of moles of B, number of moles of A plus number of moles of B is equal to 1. I want to say mole fraction of A plus mole fraction of B is equal to 1. Mole fraction of B is equal to 1 minus mole fraction of A. Like that, so many calculations we can do by using our simple logics in that. If A and B are there, if A, B, C, D are there, so mole fraction of A plus mole fraction of B plus mole fraction of C plus mole fraction of D is equal to 1 only. Sum of the mole fractions is always equal to 1, mind it. Okay. So moving ahead, calculate the normality of 0.98 weight by volume H2SO4. You can simply calculate, okay, by using this. So calculate the normality or molarity. So n factor is going to be 2. From this I think we did in the previous session, right? Yes. So mole fraction of the solvent in aqueous solution of solute is 0.8. The molality of the aqueous solution. कर सकते हैं? कर सकते हैं? Ravinder Reddy, can you do this? Can you do this? You are asking about question, can you do this? Yes. So, mole fraction of the solvent, aqueous solution. So, I just want to say, aqueous solution for the solvent is 0.2. Okay. So, number of moles, mole fraction A is a solvent, B is a solute. So, if this is 0.8, okay, so mole fraction of the solvent is 0.8. Mole fraction of the solute is equal to 1 minus 0.8 is equal to 0.2 now. That's the reason why mole fraction of A is 0.8, mole fraction of B is 0.2. So, we have a formula, molality is equal to 1000 upon molecular mass of A into mole fraction of B upon 1 minus mole fraction of B, right. So, 1000 upon here aqueous solution, now you have to take it is 18 into 0.2 upon 0.8. If you solve so, you will be getting 13.88. So, like that you can solve it. Yes. Harsh Malik, what justice you want to say? ReNEET. Why ReNEET? Harsh, why? May I know the reason? Okay. So, I do not want to discuss any controversial topics in the class. Okay. So, you want to just, you applied, you appeared NEET 2024, okay, because of some reason if you are not, so we are not here to say it is a scam, okay. So, there is a jury, they are going to take care of it. So, our job is to prepare, appear, okay. So, it is actually kind of various kinds of rumors and all. So, let us not be a part of rumor, okay. Let us part of a person who is in the topper, right. Let it be anything comes. Once we write the examination, result should come. Result scam, ReNEET, these are all kind of media or kind of things, okay. So, I personally attended the examination, I supervised so many examinations in my career, I never seen any kind of scams in my career, okay. जो भी आ रहे हैं ना, so these are all kind of like rumors only, so don't be a part of in that, okay. So, इसका फ़ायदा कुछ नहीं होगा, ओके, हमारा उसमें हमारा फ़ायदा क्या है ढूंढने का कोशिश करो बेटा. हर सॉरी, आई एम सॉरी फॉर डिस्करेजिंग यू, बट आपका अच्छा होने के लिए बोल रहा हूँ, ओके. सब बच्चे लोग, सो यू आर किड्स, फोकस ऑन एकेडमिक्स, दैट्स इट. सो जो भी आने दो, राइट. सो वी हैव टू वर्क. Got it? Right. Okay. Going ahead. What is the molarity of 0.15 normal H3PO4? H3PO4, इसका मोलारिटी क्या होगा एंड नॉर्मालिटी क्या होगा, राइट. P double bond O, OH, OH, OH. This is H3PO4 structure. So that iska Harsh Malik, you have given D, right? N value is going to be 3 because there are 3 OH groups, so that one H plus can be given, another and another, right? N factor. So normality is equal to molarity into N factor, right? Molarity is equal to normality by N factor, right? So that normality is 1.5 by 3. So 1.5 by 3 is equal to 0.5 molar. So that my answer is going to be 3. You have given answer D. Ravinder, why did you get this 1.3 beta? Where did you get it? Ishita 13.88. Answer भी नहीं है. Answer भी नहीं है. Ishita, got it? Don't retract it. Don't retract it. Okay, let it be, right? So if it goes like that, many equations we can do. The number of millimoles of H2SO4. Okay. So let us go into the solubility. पहले क्वेश्चन का आंसर था. ओके, कॉपी हमारी रख दी है क्या? So these slides I just want to give you as a notes in the PDF format. You just join in the Telegram channel and you just download it and you can go through those questions. Ravinder, ready? Fine. And आगे बढ़ना. Concept solubility. Solubility of a solute is given in a solvent present in the maximum quantity of solute that can be present as in the dissolved state in the saturated solution at a given temperature. A temperature constant होना, a room temperature में होना. Okay, no problem beta, no problem. Okay, right. So solubility can be given in gram per liter or mole per liter, right? So that is given as solubility of solid in liquid. Example, okay, salt, sugar, okay, NaCl is dissolved in the water. When a solid solute is added to the solvent, some solute is dissolved and the concentration of the solution going to be increased. The process is known as dissolution. During dissolution, a solid जो है ना, ये ionic crystal है, ये crystal dissociate करता. जब crystal form होता है, इसका lattice energy is bonded in that. When the crystal is broken, hydration energy is released. Okay. Okay, I will check it better. Ravinder, I will check it. I will check it. Okay. So this solute is a solid in liquids. After this, we will be going into the gas in the liquid. Then we discuss about the Raoult law. Here, when a solute is continuously added in the constant shaking, some solute particle solution collide with each other and get dissociated. Okay. Okay, I will check it better. Which question do you want me to check, Ravinder? फिर जाना ये वाला D250 ml, right? Yes, it is there na. Fine beta. This is fine beta. It is already solved here, right? Thank you very much. Wonderful. Such a sharp. I am very happy to have a very good interacting and the sharp students in the class. Okay, so that is 0.98. It is fine. Okay, milliliters. Okay, talking about A stage is reached when the solute, dissolved solute and undissolved solute equilibrium आता है, that is what you call it as a saturated solution. So, okay, that saturated solution is in dynamic equilibrium. So, solute and plus solvent gives rise solution, and the system is at a dynamic equilibrium, and at that dynamic equilibrium is established, and it is called as it is called as a saturated solution. The solution is that state is called saturated solution. You have to understand the term saturated solution, it is there in the ionic equilibrium also. Thank you very much Ravinder Reddy. आप जितना जल्दी चाह रहे हैं ना, okay, so definitely you will clear all the examinations that you are going to write. Okay, bless you all God bless you, right? So an unsaturated solution है, so it can dissolve some more solute in it. एक super saturated solute है, the super saturated solution is the solution excess of solute is dissolved, when excess of solute is dissolved due to heating. Okay, right. So this happens when a solute is soluble in water if hydration energy is greater than lattice energy. This is very, very important. So hydration energy should be greater than lattice energy, तभी a solute solution में dissolve करने का condition होगा. Again lattice energy and hydration energy we discuss in जब thermodynamics में है and chemical bonding में है. So solubility measure करने का एक scale है. So the solubility of a solid and liquid at any temperature is defined as the maximum amount of the solid in grams which can be dissolved in 100 grams. So it is measured in gram per liter, that is called solubility. So factors affecting the solubility of solids and liquid, first one is nature of solute and the solvent. Talking about the nature of solute, more ionic, more is the solubility. Okay, and जिस solute का हाइड्रेशन एनर्जी ज़्यादा है लाटिस एनर्जी से, ये ज़्यादा स्टेबल हो, ज़्यादा सॉल्युबल होगा सल्यूट का वजह से. सॉल्वेंट का वजह से it all depends on dielectric constant. The solvent which has high dielectric constant, in that ionic compounds are going to be more soluble. So water has the highest dielectric constant, that is the reason why majority of the ionic solids are dissolved in the water. So that water is also called as a universal solvent for ionic substances. उत्कर्ष राज, क्या बोलना चाहता हूँ? Okay, right. So temperature, this is also very important. Temperature, अगर temperature बढ़े तो solubility बढ़ेगा. Because I want to show you a solubility curve of this. When you talk about the solubility curve, solubility versus temperature, most of the solutes, the solubility increases as temperature is increased, है ना? But one thing you can see, sodium chloride, as the temperature increases, solubility is almost constant. देख रहे देखो, that is very, very, very important. That is very important. Okay, most of the cases, right? So the temperature on solubility depends on heat of a solution, and it can be explained on the Le-Chatelier principle. Okay, increase in temperature increases the solubility for the solid in liquid, है ना? But heat of solution is a sum of lattice energy and hydration energy. What is lattice energy? Somebody tell me. Ishita, tell me what is lattice energy? What is lattice energy? Okay. Lattice energy is the energy that is released. Hi, Himanshu. That is the energy released when ionic solid is formed from gaseous ions, constituent gaseous ions. और एक चीज़ है, lattice energy is what is hydration energy, the amount of energy released when gaseous ions are dissolved to form hydrated ions. Yes, okay. So solubility of solids which dissolve in liquid solvent with absorption of heat, delta H is positive. So Le-Chatelier principle का हिसाब से जब एंडोथर्मिक प्रोसेस है, as temperature increased, reaction आगे बढ़ना. Here in this example, as temperature increases, as some solubility increases. But in case of sodium chloride, you can say for sodium chloride, lattice energy is 184 kilocalories, nearly equal to hydration energy. That's very, very important. Hence, its solubility does not vary much with temperature, we can see. So that you can see in this graph, sodium chloride, her salt ka graph is going like this, her graph, her salt ka. But sodium chloride is almost a parallel line. So the reason is in the NEET examination, you have statement 1 and the statement 2 questions are very important. Okay, so assertion statement 1 and the statement 2 questions, or assertion and reason type questions. So you have these type of questions in NEET examination, right? To understand in the NEET examination, this is one statement. For sodium chloride, solubility curve, solubility is statement 1, solubility of NaCl do not vary with the temperature. Okay, statement 2, this is the statement 2. Got it? Both are true. Of course, statement 2 is the correct explanation of statement 1. So, in the NEET examination, what is the lesson we learnt? NEET examination is easy, but थोड़ा सा एनालाइज करके सही आंसर पकड़ना, राइट? हाँ, वेरी गुड, very good. So what about the effect of pressure? Pressure has little effect, I say no effect on the solubility of a solid in a liquid, because solids and liquids are highly incompressible. This is very important statement that we need to discuss, right? So if it is a gas in the liquid, you will be having utmost importance, because gases are compressible, they change their properties when the pressure is applied, but not liquids and solids. So solubility of gas, abhi to mast hai, we need to learn Henry's law. Solubility of a gas and a liquid at a particular temperature also expressed in terms of molarity or molality, or you can say the mole fraction in terms of mole fraction of gas. That is given by Henry's law. When you just say, a diagram is also there. So, it all depends on first nature of gas or the solvent. छोड़ दो, solvent को छोड़ दो, nature of gas. So, gases are compressible and can be liquefied. So, more is the compression, more is the polarity, and more is the solubility. Okay. So, with the gases like hydrogen, oxygen, nitrogen dissolve in water only to a small extent because they are non-polar. Okay. Whereas the gases like HCl, NH3 are highly soluble because they are polar and they form hydrogen bonding with water. Sometimes they react with water. Got it? So, intermolecular forces also very important. Oxygen, nitrogen and carbon dioxide is much more soluble in ethyl alcohol than water, doesn't matter. So, effect of temperature. When gas dissolve in the water and form a solution, this process is exothermic. This process is exothermic. In this exothermic process, delta H is going to be negative. According to Le Chatelier principle, as temperature increases, solubility. Ravinder, tell me, increases or decreases? Increase or decreases? Increase or decreases? Apply Le Chatelier principle. Ravinder. Himanshu. It decreases. It decreases. Okay. So, effect of pressure. अभी तो आएगा Henry's law. अभी तो आएगा Henry's law. When the gas is applied pressure, it is pushed into the liquid. So that as pressure increases, gas solubility increases in the liquid. Hope you understand. Ishita, you said correct. Okay. So, quantitatively the effect of pressure on the solubility of gas. So, the mass of given gas solubility is directly proportional to the pressure applied. Okay. So, I want to say weight of gas is directly proportional to pressure of a gas. Okay. You can also say, so if this is a piston, you see, this is a piston, this is the gas and this is a liquid, right? If you just see piston is upper and how many 1, 2, 3, 4, 5 molecules of gas are present in the liquid. If you push down, so that force is applied and the piston down, so the pressure is applied. So, more number of gas molecule enter into the liquid system. Hope you understand, right? So, solubility increased pressure increases the solubility. समझ में आ रहा है क्या? Clear? Many students are there. You just simply say. So, I mean to say pressure of the gas. Okay. So, solubility is directly proportional to the pressure of the gas. You can also say pressure of the gas is directly proportional to mole fraction is the function of solubility. Mole fraction of gas is the function of solubility. So, the pressure of the gas is equal to Henry's law constant and mole fraction. If you use this formula, Henry's law, you can play like anything. What is KH beta? KH is called Henry's law. KH is called Henry's law. समझे? Now आगे बढ़ना. Any doubt? Ravinder kept quiet. What happened to you, beta? What happened to you? Now, the solubility of a gas in a liquid at a particular temperature is directly proportional to the partial pressure of the gas in equilibrium with the liquid at that given temperature. That's good. Pranav, hey, you're late. Why? When did you come? Wish किया नहीं? Wish किया नहीं? हाँ. So that's what we have given. Henry's law directly is given. So the most commonly used form of Henry's law and may be defined as follows. The partial pressure of gas is directly proportional to the mole fraction. It's okay, beta? It's okay. So partial pressure and mole fraction. Partial pressure of the gas is directly proportional to the mole fraction. एक ग्राफ का हिसाब से experimentally determined. This gives a straight line passes through the origin. Learn the concept. And this straight line follows y is equal to mx plus c, a straight line equation, and this straight line slope gives Henry's law constant. Slope is equal to tan theta is equal to Henry's law constant. ख्याल पे रखो. Huh? Right. So I want to say here P gas is equal to Henry's law constant, mole fraction of the gas. Now I have a doubt. What is this? KH is called Henry's law constant. कौन बोला रे constant का? टेक्स्ट बुक में लिखा हुआ, इतिहास में लिखा हुआ, ये कांस्टेंट है. कांस्टेंट वैल्यू, ये जो कांस्टेंट होना चाहिए हमेशा. बट Henry's law constant is a constant for a gas at that given temperature. If you change the gas, Henry's law constant value changes. For a given gas, if temperature value changes, Henry's law constant value changes. Then how can I say this is a constant? I don't know, but people say it is a constant. Textbook also says it is a constant, so it is a constant. है ना? Right. Now, so different gases will have different KH values at the same temperature and the same solvent. From these values, you can say, yes, you can say at a given temperature, yes, temperature, different gases will have different Henry's law constant values, right? Do we have to memorize these values? बिल्कुल नहीं बेटा. I just want to say here, for a gas, we know that P gas is equal to Henry's law constant, mole fraction of the gas, right? So, mole fraction of the gas inversely proportional to Henry's law constant. अगर मोल फ्रैक्शन गैस बढ़ेगा तो सॉल्युबिलिटी बढ़ेगा, है ना? यस. सो जिस गैस का हेनरीज लॉ कांस्टेंट ज़्यादा है, इसका मोल फ्रैक्शन कम होगा. का मतलब क्या? सॉल्युबिलिटी कम होगा. सॉल्युबिलिटी कम होगा. दिस इज वेरी वेरी इंपॉर्टेंट रिलेशन. ऑन डीजे एडिट्स, want to say something? I didn't understand. Hi. Hello, how are you? I think your name भूल गए मैं, अभिनव or some. Yes. DJ edits, you want to say something better? I couldn't understand what you typed there. Okay, let's go ahead. Acids and bases we will discuss in ionic equilibrium. This comes in the month of next 11th topic after organic hydrocarbons. In the June we will discuss it. Sorry, Anirudh. Okay. फिर से अरे बेटा यू नेवर चेंज योर नेम, अननोन के ऐसे लिखते हैं. ओके, राइट. सो limitations of Henry's law. Henry's law is applicable only if the following conditions are satisfied. 1. The pressure should be not be too low, not be too high. Intermediate pressures में इस्तेमाल करना है. Gas should not undergo compound formation when you dissolve it. So there shouldn't be any chemical reaction between the gas and the liquid. ठीक है बेटा? हाँ, right. So let's talk about H2S is a toxic gas with rotten egg smell. ये NCERT में है, ये NEET का भी चलेगा. That's why I say these sessions are quite useful for those students who are in 12th, passed from 11th or dropped at 12th. Okay, jaldi. Normality we discussed beta, we discussed. We just go through the previous recording, you will understand. ठीक है, जल्दी. 1 minute. Yes. How many of you could give this correct answer? If the solubility of H2S in water at STP is 0.195 mole kg inverse. So I mean to say here key point. Okay, you are asked to calculate Henry's law constant, right? So we know that pressure of the gas is equal to Henry's law constant and mole fraction of the gas, right? So pressure of the gas Henry's law constant, number of moles of gas plus number of moles of water. Right? So that we will understand what is given. At STP, pressure is equal to 1 atm, है ना? I just want to write 1 atm kh. Into number of moles of gas, molality. So number of moles of gas is equal to 0.195 per kg. So number of moles of water is equal to, for 1 kg it is weight by molecular weight. So number of moles of water is equal to कितना होगा? हाँ, edits. In this way you have, yes, I'll make it. 1 kg of water contains 1000 grams. Molecular weight of water, DJ, it is 18. So number of moles of water, if we solve it, 55.55 will come, right? So that 0.195 upon 0.195 plus 55.55. Now this variable is calculated. Hope you understand how to solve this question. Pranav Balaji. Yes, fine beta. Any doubt here? So if you solve, so आपका आंसर प्रेजेंट करना चाहता हूँ 28.5.6 will come. Okay, that is given like this only. 28.5.78 m is the first option, is the correct answer. So you all understood this? You all understood this? Yes. और एक करना है? तैयार है? काफी है? That's good. That's good. That's good. Which of the following gases will greatly deviate from enriched line water? Any answer? Any answer? Yes, Ishita? Right. So the gas which is more polar more soluble, more deviation, because more polar gases is going to polarize and ionize in the water. So that my answer go here, ammonia. So such a logical questions बेटा, मेरा क्लास में आपका ज़्यादा लॉजिक्स पकड़ रहे हैं. So that it is ammonia. So low concentration of oxygen in the blood and tissues of people of a high altitude is due to. Answer? मैं एक चीज़, एक छोटा सा कहानी है. So high hill, this is hill. Okay, यहाँ पर एक आदमी है, right? You know the people who are just cliff and hanging, or what you say, mountaineers, Everest. These people just try to feel it. It is a lot more feeling about anoxia, because they can't breathe. They can't breathe. Why they can't breathe, beta? Because here we are happy. We are all happy here. Okay, we are all happy here. Because the pressure of oxygen is sufficient. So that we people on the surface of the earth, we experience. But here what happened? The pressure of oxygen is less. So when it talks about these are the lungs, okay, the oxygen goes here, oxygen goes here, oxygen goes here. If P oxygen is more, it can nicely go into the bloodstream. If P oxygen is less, it cannot go into the bloodstream. That's the reason why partial pressure of oxygen is less. The person who are at high altitude suffer to take the oxygen due to low partial pressure of oxygen. So they experience anoxia. So low pressure. Okay, low atmospheric pressure, option 2. Got it? Clear? Yes, that's good. So और एक क्वेश्चन तैयार है आपके पास. So talking about the vapor pressure. So vapor pressure I just initiate and complete it. Okay, Vishwas Kumar, hi. Not coming nowadays, why? Pressure is inversely proportional to altitude. Okay, that's a different way. Okay. So, what is vapor pressure? I just want to discuss one thing here. This is a vessel. These are the surface molecules of a liquid. So, these liquid molecules and this liquid is kept a lid, closed lid. So, what I mean to say, these are the liquid molecules. And I want to show you the liquid molecules which are present on the surface of the liquid. You have to understand this. You want to understand rate of evaporation, lowering of vapor pressure, relative lowering of vapor pressure. ये समझना जरूर है. Now, according to kinetic theory, these liquid molecules are always in random zigzag motion. When they are in a random zigzag motion, they make collisions among themselves and also make a collision on the surface molecules, those molecules that are present on the surface, so that these molecules are perfectly elastic. As a result of this, what happened? Kinetic energy of this molecule is transferred to this molecule, so that this molecule escape out of it. So, this is converted to this. So, like that, this process is called as evaporation. So, this is the liquid. This liquid is converted into vapor. This process is called evaporation. In this evaporation, again this gas state make a random zigzag motion like this, okay, like this. No, those molecule which will come down, they convert back, vapor is converting back into the liquid. है ना? What is that process? Liquid is evaporating, that is called evaporation, and the vapor is converted to liquid, that is called condensation, and this process is called as dynamic equilibrium. जब इसका dynamic equilibrium आएंगे, you can say this is at equilibrium, dynamic equilibrium. In this dynamic equilibrium, these liquid molecules जो है ना, these liquid molecule exert some pressure on the surface of the liquid. That pressure is called as equilibrium vapor pressure or vapor pressure. Got it? So, I just want to say the pressure exerted by vapor molecules of a liquid when they are in equilibrium with the liquid at a given temperature is called vapor pressure of the liquid at that temperature, or you can also say equilibrium vapor pressure. Now we are in the real part of the solutions chapter, right? So, the liquid molecule making a pressure on the surface, you can see. Okay. So, evaporation which has reached equilibrium when the liquid surface is said to have reached saturation. So, this is also called as saturated equilibrium vapor pressure or equilibrium vapor pressure, or simply you can say it is a vapor pressure. Are you getting or not? Clear? You all understood the definition of the vapor pressure, right? Got it? Yes. Very good. Now, my dear students, today actually what we did in the previous class, as this class is ended in the previous week, most of the time we spent with revising the concepts, and today we discussed about solubility majorly, solubility of solid in liquid and solubility of gas in liquid. Now we entered into the vapor pressure. As this vapor pressure goes on, we step into the Raoult law, later we just go into the colligative properties. So tomorrow and day after tomorrow we focus on the solutions on colligative properties and we finish it. Okay, so we are done for the day. My dear students, we are doing the best for you and you are also definitely doing best for you again. So we request you to just hit the like button and share with your friends and subscribe. In the description box it is given, join in Telegram channel. Now thank you very much for today's class, and tomorrow we will meet with more stuff in vapor pressure and Raoult law. Okay, so homework it is there in the slides itself, you can take it. Okay beta? Okay, see you, bye bye, thank you.